Hey there, and welcome to The Explainer. Today, we're going to dive into something really cool, a super powerful way of building software. In fact, it's the secret sauce behind pretty much every app you use. It's called object-oriented programming.
Okay, let's try a little thought experiment. Imagine you're trying to build an awesome spaceship, but all your toys are dumped into one giant, messy bin. You're looking for that one tiny red piece, but it's buried under wheels, action figures, you name it. Total nightmare, right? Almost impossible.
Well, believe it or not, for a really long time, that's kind of what coding was like, just a big, messy toy box. This got so bad it actually had a name, the software crisis. Basically, programs were getting so huge and tangled up that they were becoming a total disaster to build or even just to fix.
So, to clean up this giant mess, some really clever people had to come up with a whole new way of thinking, a big idea to bring some order to the chaos.
So instead of that big jumble of loose parts, what if we made special kits for our toys? You know, like a car kit that has all its own wheels and its own engine right inside it? And here's the cool part, it knows how to drive. In the world of coding, we call these awesome little kits objects.
And this idea, this smart block idea, was a total game changer. By organizing all the code into these neat little blocks, programmers could finally start building amazing, huge things without getting totally lost.
But these aren't just any old blocks. Nope, they follow 4 secret super rules that make them incredibly powerful. Think of them like superpowers for code. Let's check them out.
All right, these 4 rules are what make the whole thing tick. They're the magic behind object-oriented programming.
Okay, rule number 1, encapsulation. The best way to think about this is like a protective bubble. It means all the important parts are kept safe and sound inside the block, totally protected from everything else on the outside.
And why is that so important? Well, imagine your little brother comes along and grabs a wheel from your car kit and loses it. That's what can happen without this rule. But with the bubble, all the car parts are safe inside. Nothing gets lost or broken by accident. It just keeps the code safe.
Next up, we've got inheritance, and this one is awesome. It's basically like a copy-paste superpower. You can create a brand new block just by copying an old one and then adding some new features.
Think about it. Before this rule, if you wanted to build a flying car, you'd have to start completely from scratch. But now, you just copy the regular car block and add some wings. Boom! You get all the original car parts for free. It saves so much time.
Okay, rule number 3 is polymorphism. I know, it's a big word, but the idea is actually pretty simple. It's like a shapeshifter. It means the same command, like go, can work differently for different blocks. So, without this rule, you'd need a different button for everything. A drive button for the car, a fly button for the plane, a walk button for the robot. Ugh, so complicated. But with polymorphism, you can just have one go button. The car knows it's supposed to drive, the plane knows it's supposed to fly, and the robot knows to walk. It makes the code super flexible.
And our last super rule is abstraction. This one is all about hiding the complicated stuff and just showing you the simple controls you actually need. Think of it like a simple remote control. I mean, imagine if to drive your toy car, you had to know all about its engine and gears and wires. You'd never get to play. Abstraction hides all that messy stuff. You just press the go button on the remote, and it works. All the complicated stuff is hidden inside, and that's exactly why we can all use these amazing apps on our phones without needing to be expert coders.
So, let's put it all together. You can really think of these 4 rules as a superhero team. Encapsulation is the hero who protects the gear, keeping the code safe. Inheritance is the mentor who passes down powers, making code fast to build. Polymorphism is the leader who can yell one command, go, and every hero does their own thing, which makes the code flexible. And abstraction, that's the hero who just saves the day without you needing to see all the complicated secret plans. It just makes things simple to use.
Okay, so with these super rules in place, coders are ready to build, but what do they actually use? Well, they have some pretty awesome power tools to help them out. They've got a workbench called an IDE to keep all their blocks organized. They have a speed checker or a profiler to find any slow parts and make them faster. And get this, they even have a time machine. It's called Git, and it lets them go back in time if they ever make a mistake. How cool is that? So, why is all of this so cool? Why does it matter?
Well, it's because these smart blocks and super rules are literally how coders build your favorite games, websites, and apps. It's how teams of people can work together to create these huge, incredible programs we use every single day, without the whole thing turning back into that giant, messy toy box.
So, next time you're playing a game or using your favorite app, you'll know the secret. It's all just a bunch of these smart code blocks working together. And that kind of makes you wonder, right? If you had these smart blocks, what amazing thing would you build? Thanks for watching this explainer.